Hi folks, Mr. Long here. Going to do a quick screencast. These are AP preparation questions. For the most part, they're fairly straightforward. So what we're dealing with here is velocity or position, velocity, and acceleration. So rectilinear motion. These are questions that the AP folks have provided, so there's some mistakes in them, which is normal. And I think anyway. So what we've got here is in this first question is we've got a graph that is showing position of a particle moving in one dimension. That's what rectilinear motion means. So you can think of it as moving up and down. So from here up is moving in the positive direction. From here moving down, that's the negative direction. And it's pretty hard to see the numbers on here, but anyway, the y value right here down low is -1, and the y value up here is 4. So it says find acceleration at 7 seconds. And this is a graph of s of t, position. S of t is position. So what we know is that the derivative of velocity, that velocity is the derivative of position. So v of t equals s prime of t. So I have to get the slope of this graph to get the velocity. And for this one, I guess the question is, so this is linear, right? At 7 seconds, 7 seconds happens to be right here. I know that's hard to see, but at 7 seconds, I'm on the curve right here. So the position graph is linear there. So what's the derivative of a linear graph? It's just a constant, right? So what I could do is I've shown here that delta s, the change in slope, is 5. The change in time is 4 seconds. So in the case where you have a linear graph, the secant slope and the tangent slope are actually the same thing, right? Because the secant overlaps the tangent. And that's only true for a linear graph. So that means that the actual derivative, the rate of change that's instantaneous of position, is just the slope, 5 over 4, 1.25. But that's the slope of the tangent. And so that's the velocity. Well, if the velocity is a constant, right? If the velocity is a constant, then that means that that the rate of change of a constant is 0. So in fact, the acceleration is 0. So think of this. To go from position to acceleration, you have to differentiate twice. Well, this is the position graph. You differentiate once, and you're going to get a horizontal line coming across like so. And if you have a horizontal line coming across, then the derivative of that will be 0. So the answer here is the acceleration at time 7 is, in fact, 0.